Hi, this is Doug Priestley with the Nortech Technical Service Department, and I'm pleased to announce the availability of Nortech Global HVAC Charge Calculator. After many years of development and testing, we have developed a tool to help in assisting in the charge of microchannel ACs, microchannel heat pumps, and then mixed technology coils like fin and tube indoor evaporator coil with a microchannel outdoor unit, or vice versa, microchannel indoor coil with a fin and tube outdoor unit. This is a web-based app, meaning that it's not an application where you go to one of the Google Play Store or Apple application store. This is a web-based app, meaning you can use it on a laptop computer or any mobile device. It is mobile friendly, meaning that when you're on your iPhone or your Android type device, that the screen is fairly easy to read and everything fits on the mobile phone screen. Some of the tools you're going to need: one is a set of gauges, two, a reliable thermometer to measure superheat, subcooling. You also may want a third item, which is a thermometer that will measure wet bulb temperature inside the home. While the application doesn't require you to know the wet bulb temperature, most manufacturers, including Nortech Global HVAC, do require wet bulb temperature to accurately charge any system. Before you get started with all that, you want to ensure that the airflow of your furnace or your air handler is set properly for the size of the air conditioner or heat pump system you've installed. And you want to also ensure, based on the QRD, that if it is a piston system, that you have the proper piston. Follow the QRD, and if a piston change needs to be made, you will see the pistons that are contained with the outdoor unit. Joining me is Greg Bruntz. Greg is going to give me some data as we go through showing you how to use the app. First thing we want to do is we want to log in to the website. So you want to go to chargecalculator, all one word, .com. First thing it's going to ask you for is your zip code and your email address. So I've preloaded the zip code and my email address here. And then I'm going to click sign in. First thing it's going to ask you is for your base charge. As always at Nortech Global HVAC, we're going to want you to refer to the QRD that came with the unit to ensure that you have the correct charge. If you're unsure of that charge, we can look at that a little bit later in the app. But if you're unsure if you have the correct factory charge, if you're coming up to troubleshoot or diagnose a system that may have a refrigerant problem, remove the refrigerant from the system, refer back to the QRD. Another great thing is EdgeTech HVAC is very mobile friendly, even though it's not an app. Get into the literature library off of Nortech Global HVAC website, and you can look up the QRD from your mobile device too. So it's very mobile friendly. You can get to that information fairly quickly if you don't have the information with the unit. A lot of guys will take the literature with them when they're done installing a system, but as long as you've got the model number, you can go back into the website, the literature website, you can get that information off of the QRD. So the first question it's going to ask me on the base charge on the charge calculator is what type of system I have. For our example here, we have a microchannel heat pump with a microchannel indoor air handler. We're going to select done. The control type is a fixed piston, fixed orifice. And we checked this before, so we know we have the proper piston in there and we know we have the airflow set properly. On this system, it is a 14 SEER heat pump. We're using a 3/4 inch diameter suction line. Total line set length, we've got a small line set, so we'll just leave it at the factory charge of 15 feet. And then the capacity of the unit, we want to look for that. You can look at the model number of the condensing unit to ensure that you have the proper capacity, and I believe this one, Greg?
2-ton with a 2-ton.
So we have a 2-ton microchannel 14 SEER heat pump. We'll click on that. The charge, there are two ways you can do it. You can do the actual charge that comes off of the QRD. I don't have a QRD handy with me, but we can do that later. Or you could do a calculated charge. Keep in mind that the calculated average QRD charge is what's going to be put in there. It may not necessarily reflect what the factory charge is. It is always best to get the factory QRD charge for that system if you know that that's in there. If you're just kind of guesstimating at what it is, we have averaged all 2-ton units across all model numbers and serial numbers, and then that's the average QRD charge. So we're just going to hit that. So on this example, we use the calculated charge, which was 95.6. I believe the QRD charge is right around 99 ounces. So we're fairly close. I'm comfortable with this number. So I'm going to go ahead and accept that total base charge of 96 ounces. The next thing the website is going to ask me for is calculated indoor wet bulb temperature or measured indoor wet bulb temperature. So if I go with the calculated, our outdoor temperature for this purpose is only 70 degrees. So I'm going to move the slider over to 70. Our humidity level in here, let's just guesstimate that it's 50%. Our indoor dry bulb temperature is 72 degrees. So it's calculating our indoor wet bulb at about 60 degrees in here. Now, if you want to, you can go with measured indoor wet bulb temperature. So we'll click on measured. We still have a 70 degree outdoor. Greg, what do you have for an indoor temperature?
72.
Okay. And what's your indoor wet bulb?
60.5.
So I've selected 60.5. So with this thermometer, it gives me the ability to measure wet bulb temperature inside the home so I can get an accurate reading. Keep in mind, I've spent a lot of time looking through other manufacturers' install instructions and charging procedures, and 99% of them ask for indoor wet bulb temperature when charging their systems. This runs roughly anywhere from $40 to $60 at your local distributor. It's a great tool. It gives you relative humidity. It gives you the humidity indoors, and it also gives you wet bulb temperature. So you can get a lot of good readings with this thermometer. And as I said, this is made by Fieldpiece. A lot of your meters will have accessory heads that will allow you to measure wet bulb temperature. It's fairly easy to get that information now. So keep that in mind when you're using this web-based application. So once I've entered in the temperatures, it now asks me to let the system run for 15 minutes before you take your first measurement. So we're going to go ahead and do that, and we'll be back shortly when we've allowed this timer to run. So now that we've started up the unit and allowed it to run for about 10-15 minutes, we're going to go ahead and start entering in some of the data that we've gathered off of our gauges and off of our thermometers. So Greg, can you give me the head pressure or liquid pressure?
Head pressure is 245.
And what is the liquid line temperature?
Liquid line temperature of 78 degrees.
What's your suction pressure?
116 pounds.
And what is your suction line temperature?
Suction line temperature 60 degrees.
So once I've entered in the pressure numbers and pressure temperatures, I'm going to click Calculate Charge. Okay, based on the charge results, the charge calculator is telling me I'm slightly undercharged. I've got about 90% of the system charge in there. It's asking me to add 9.1 ounces of charge in there. The charge results is really what I'm kind of interested in. I know I may be a little off on charge on this system, but charge count, it's asking me for liquid subcooling. My targeted subcooling is 5.3 ounces. My actual subcooling is 4.3, so that indicates to me that I am slightly undercharged there. My suction superheat is way out of whack, so I'm starving that evaporator with it being at 21 degrees of superheat. And then my targeted superheat, which is great about this charge app, it gives you a range of superheat that you want to be at. My targeted superheat should be within the minimum 10 to 14. So in this case, if I'm sure I have got the proper charge in here, based on weighing in the charge, I may add a couple of more ounces to the system to see if I can get within those ranges too. Now keep in mind, things that affect charge. Our factory charge is done in a lab. Your system your ductwork might be slightly restrictive. You may not have the proper airflow across the coil. There are many other things that I'm going to take into account before I'm quick to condemn the charge. I want to make sure that I've checked my temperature drop across the coil. I want to make sure my ductwork, I'm going to check my static pressure. I'm going to look at my airflow, make sure my blower motor's set to the proper speed. All of those things. But I think in this case, I would go ahead and add a couple of ounces, let the system run, and see where we're at with it. So based on the numbers we had for this system, we went ahead and added added another 4 ounces of charge to the system. We determined that the system was low on charge. Ductwork and everything was in pretty good shape. We determined that airflow was set correctly, our static pressure was okay, and we determined that we needed to add a little more refrigerant, so we went ahead and did that. But as you can see, you can use the charge calculator as an aid when you're starting up a system, brand new system. As long as you weigh in the charge properly, you can determine if you're charged accurately for your installation, but you can also use it as a troubleshooting tool. The application gives you targeted superheat and subcooling numbers that we've determined through extensive testing, really over 2 years of testing in the laboratory, giving you targeted superheat and subcooling numbers that you need to shoot for when troubleshooting a system. So if those numbers are out of whack based on what the charge is and what you're actually reading, you might look at ductwork. You may look for a dirty filter. You may look for a dirty coil. You may look for a dirty blower assembly. There's a lot of different ways you can go with it. If you're unsure of the charge in there, make sure you weigh in the charge. Again, almost all manufacturers these days are asking you to weigh in the proper amount of refrigerant. Again, remember, as we get into these more high efficiency systems, charge is becoming critical to get those efficiencies. So most manufacturers are wanting us now to weigh in refrigerant to it. Use this to help you diagnose and troubleshoot mixed technology systems. I know we did have some matches out there where we had microchannel outdoor units mixed with microchannel indoor and vice versa when we were making the changeover. You can use this tool as an aid to help you diagnose refrigerant system troubleshooting. Really great app. Kick the tires on it. If you have any problems with the app, give us a call in technical service or shoot me an email, doug.priestley@nortec.com. I thank you for your time. Please use this app. It's going to be, I think, a wonderful aid in helping you quickly charge a system and also quickly verify that you do have the proper charge in the system. I'd like to thank Greg for helping us out today on using this charge calculator. Thank you for your time. Hope you found the video informative. Remember, ask your questions at any time. I got a couple of questions already, but hit the ask the question mark and we'll get your questions answered. I hope you guys really give this website a shot. I think it's going to be very helpful for the field technician out there. It'll be helpful if you're troubleshooting. I believe it does. It's some of the cases that I've been punching numbers. I've been experimenting with the phone version of it. It's been very helpful, and one of the nice things that hopefully I'll show you here in a little bit here on my phone is that it is very mobile friendly. You do need a Wi-Fi connection or you have to use your cellular data at this time. Keep in mind, the more hits and the more uses and the more we kind of overrun this mobile website and regular website, we'll be able to get it converted over to an app feature for you. Right now, it's currently not that way, but I do have it bookmarked on my iPhone to get to it whenever I need it. I've been using it as we've gotten troubleshooting calls in through the tech department, and have really found it useful and pretty friendly to use. One thing I want to make sure that you do is make sure you have some way of measuring wet bulb temperature. You don't need you could use a sling psychrometer if you wanted to, but you don't need that these days. As in the video, as I showed you, there's many digital ways to measure wet bulb temperature out in the field now. We do have an adaptation out there that you can take outdoor relative humidity and plug those numbers in, and it'll give you a guesstimate on what wet bulb temperature might be within the house itself. But I would recommend that you pick up one of those digital sling psychrometers that will measure that for you. The one that I have measures wet bulb, relative humidity, dry bulb, all that neat stuff, and that'll make it a lot more accurate when you're trying to get the correct charge in there. First question I have is from Greg. Is this an app? As I just mentioned, no, it's not. It is a web-based program, but it is mobile friendly. I've kind of got it pulled up here on my phone right now. If you go to chargecalculator.com in your web browser, Safari, that's what I'm using, but you can use Google. It works with Android too. But as you can see on there, that it is mobile friendly. So it's not, you don't have to move the page left or right. You just punch in your numbers there, and you should be good to go. I'm just going to select, let's try a microchannel heat pump. We'll try fixed orifice. Just 3 ton for sake of picking something. Let's do a 14 SEER. We do 13 SEER units on here too, the BD units. We do allow, there's the ability, scroll back up here. There is the ability to do microchannel indoor-outdoor with fin and tube. On the AC side with fin and tube indoor, microchannel outdoor, or vice versa. Microchannel indoor and fin and tube indoor. So you do have that ability there, but we'll stick with the heat pump. Heat pump is really nice that it'll allow you to put that in there. Remember total line set length. Let's just pick 25. Back out of there. We'll pick 25. Done. QRD, we don't know, so I'm going to go with the calculated charge. Keep in mind that you can get on our literature website too, which is mobile friendly, and get that actual QRD, or you can pull that factory charge. You can get the factory charge, then go to the QRD and reference that. So we're going to calculate the base charge. Oh, I forgot to put in my vapor line. We'll just say 7/8. Calculate the base charge. So that gives me a calculated charge. I'm going to calculate the outdoor. I'm just going to select right around 90 degrees. Yeah, we'll just say it's 55 outside or 58. And then we'll just go with those numbers right now. Now, at the very bottom, you'll notice it says let the unit run for 15 minutes before you take your first measurements. Now, on the heat pump, that's going to be important. A lot of times starting out on a heat pump, you're going to have to wait a little bit because you'll have zero subcooling, and you really don't want to add charge too quickly if you've got zero subcooling on that. So wait the 15 minutes if you can. If you can go take some other measurements, confirm what you have on indoor wet bulb or relative humidity. let that run for a little bit so we can get some accurate temperatures, especially when it's real cool out in the heat mode. Again, liquid pressure, I'm just picking random numbers here. And 125, and we'll just say 45, done. So we'll calculate the charge. So it looks like, just based with the numbers that I put in here, I'm overcharged slightly. I don't have to wait another 15 minutes. If I remove charge, I can wait another 3 minutes, and that's what they're asking. You can click start the timer. It also gives you the charge count, percentage of refrigerant in the system, 103. Remember, we calculated that QRD charge. We didn't put the accurate, the actual QRD charge in there. We have a suction superheat of 2.6 degrees. Our liquid subcooling is 0, which isn't good. Our targeted subcooling is -0. Well, again, we're calculating. We got to remove some refrigerant out of there. In our targeted superheat minimum, you want to be between that 6 and 10 degrees. We would then wait 3 minutes or so, and then you would remove that charge and then start up the system and then plug the numbers back in. Fairly simple, fairly straightforward. Let you know where that refrigerant's at within the system if you're using the targeted and the targeted superheat and subcooling numbers. It's going to give you kind of what I like to think that for me, I can visualize based on those numbers where that superheat and subcooling is at. So, you know, I think it'll be a beneficial tool for everybody out there. We would recommend, as always, use it in the cooling mode, but this allows you to use it in cooler temperatures and lets you use it in the heating mode on the heat pump side. Let's go to our first submitted question. I only noticed that the charge calculator allows 16 SEER. Can we use it for the 23 SEER? That's Hector with RE Michael. No, at this point, we're only 13 through 16 SEER on that. I think eventually we'll get to the 20 SEER, but that's going to take some time. As we've been developing this has been in development for almost 2 years now. And essentially, we've had to go back in and run these systems and get the data points. And it's very time-consuming and takes a lot of time to get that data and put it in there so we have an accurate tool for you guys to use out in the field. So I'm sure 20 SEER will be coming down the pike, and we'll get there as close as we can and get it out there as soon as we can. But this is really for the 13 to 16 SEER units that are out there right now, which majority of the units out there are those SEERs. And will help anybody that just comes upon this thing without a QRD or with a QRD be able to determine how to charge that system accurately. Again, don't forget to submit your questions, and we'll get them answered for you. Can we balance the refrigerant charge at very low temperatures like 0 degrees? I would, me personally, if it's a heat pump, I would weigh in that charge when you're down that low. If you want to use this to give you a guide of where you're at on refrigerant charge in those temperatures, it's going to be a little bit iffy there. I'd be taking a lot more readings and doing a lot more checks to verify that refrigerant. We would recommend that you're, within normal ranges. 0, I know, is normal. It looks like this is from Corbat up in Canada. I would be looking at other things at 0 degrees. I wouldn't solely rely on the charge calculator. My recommendation would be still to charge that refrigerant normally. Again, don't forget to answer or submit your questions, and press the submit button and we'll get them answered for you. how close, this is from Scott with Fire and Ice. How close is this generic superheat calculator? I don't know because I really haven't looked at, I know there are other apps out there. I know Emerson has one out there. I know other manufacturers have them out there. This is done with testing on our equipment. So it's not generic numbers. While we allow you to put a generic number in there and calculate the charge on the app, it's really with our equipment, and we gathered the data. We actually ran these units and took the data from running those units and applied it to this charge calculator. So I can't say that it won't work on another system and with other manufacturers, but we haven't tested it with other manufacturers' equipment. Copeland, they're basing it off of their compressor data points on that. So just keep that in mind. I would just keep it to ours. I've done we did some off-site testing with a technical school here in the state of Missouri, and we did try it on some other manufacturers' units, and it wasn't that far off. But I'm not going to recommend that. As I said, you're going to kind of be on your own with that. We're not going to be able to validate whatever findings you have with other manufacturers' equipments. So, again, submit your questions on the screen and then click submit. Let's see here. Bob with Avco Supply. Why not charge the system's manufacturer specs? 17 degrees subcooling at 85 degrees outdoor. Well, remember that our microchannel systems use less refrigerant, thus they become a little more sensitive to superheat and subcooling, depending on what metering device you're using. That's going to change a lot more rapidly than it would with a fin and tube system. So the old rule of thumbs, I know where you're going with this, kind of don't apply because they're going to change. Looking at some of the data, you'll see, what's the old 95.5 rule? At 90 degrees, you're going to have, or at 95 degrees, you're going to have 5 degrees of superheat. That's going to vary with the load. And depending on it, we got smaller amounts of refrigerant. We're much more efficient with those smaller amounts of refrigerant and with the microchannel coil. I would be very careful in going with the rule of thumb. So it's going to vary a little bit, and use the charge calculator, compare it to your charging charts. Make sure you're again, the most accurate way is charging by the QRD. Bob with Avco is wondering, what does QRD mean? QRD stands for Quick Reference Data Guide. They come in the condensing units of all of our systems. The QRD, or the Quick Reference Data Guide, gives you the electrical information, the system dimensions, height, width, also gives you weight. It gives you the factory charge that came with that unit. It also gives you all the matchups that can go with that condensing unit. And with that condensing unit, you may have noticed a baggie full of pistons that came along with it. QRD tells you what piston you need to use with that system. There are cases that you're going to have to change the piston on the indoor coil. And in some cases, depending on what you're matched up with the indoor, you may have to change that piston in the outdoor unit. So keep that in mind when you're looking at the QRD. It also gives you airflow. Remember, everything that we're basing on is, number one, the first thing I would do when I install any air conditioning system, I don't care if it's Nortex or any of the other manufacturers, make sure your airflow is set correctly for the size of that unit. Or the old, again, we're getting back to rule of thumbs, the old rule of thumb of 400 CFM per ton of cooling. no longer applies with these high efficiency systems. You're going to run anywhere from 325 to 350 in some cases, just depending on the size of the equipment. In the quick reference data guide in those grids, you'll see a piston or TXV change if needed. It'll give you any additional refrigerant you need to add to that system. Remember, we send the unit with a factory charge, and then based on the indoor coil or air handler you're using, that charge may differ. I guess in a perfect world, we'd use, with the outdoor unit, we would have one A coil and one air handler. Well, the field has asked for many different air handler uses. So we have A and B width cabinets. We have B and C width cabinets. So that charge is going to change with that. So that's going to tell you what additional charge you need to add. And then also included in there is the airflow that it should be set to. So you need to set your, if it's a PSC motor, you need to select a proper speed tap. If it's a fixed speed, high efficiency motor, you'll need to set the dip switches for that. And then if it's a true variable speed, high efficiency motor, a Vichy motor, you need to set the airflow for that too. Measure your duct static. Make sure you get that blower speed setting based on your duct static. So keep that in mind when you're putting that in there. The airflow is so critical with all manufacturers' units, not just ours, that you need to set that properly. Then you can properly charge the system that way. Make sure you have a good thermometer too. Do not use a laser thermometer. I can't tell you how many countless calls that we get into the technical service department during the summer on a daily basis where somebody's got a laser thermometer and they're just shooting that temperature. Use a thermometer with thermocouples. If you've got a dedicated digital thermometer, that's great. Most of the meters now have temperature readings on that with a thermocouple. Grab those numbers. That's the most accurate way and most accurate way to get the temperature. Do not use a laser thermometer on that. On the heat pump side, Corvette also is asking if it has to be in cooling mode. No, you can charge in heating mode. We want to be, we want to, can we use it in lower temperature? I'm going to check with engineering on it. I know they recommend 50 degrees, but let me double check and I'll get back with you on that one because I'm not 100% sure on that. I don't want to give you the wrong answer either. What is the app's name? And I'm sorry if I forgot to tell you. To get to the website, actually, it's not an app. Get to the website. Go to chargecalculator.com. Just hit that in your web browser search. Once you find that, click OK. And it should bring you up to the main page. Remember, chargecalculator, all one word.com. It'll ask you for your zip code, and then it'll ask you for an email address, and then all you have to do is click sign in. We do not use these email addresses to sell or anything like that. The area code is when we're gathering the data for the charge website. We want to know where this is being used. We're not going to contact you using your email address or anything like that, but that'll get you into there and get you going with the on the website. Again, the more uses we can get, the more we can justify in converting it into an app, which is ultimately where we want to get to. Again, don't forget to submit your questions. We're kind of running a little low on questions here. As I said, I just make sure that you give it kick the tires on it, use it on your next install. Give it a whirl, see how it works out for you. We know there might be some bugs. If you have any bugs, go ahead and email us. Let us know so we can get it fixed. If it's not working for you, just shoot us an email. Let us know. We'll get a look at it. I try and get in there every day and just make sure everything's working properly. We do go back through the data. The more real world data we can get, we can compare to the laboratory data that we have, and we can get those anything corrected that we might need. So with that, since there aren't any other questions coming in, I want to thank you for your time. If you have any questions, just shoot me an email, give me a call. My email address is Doug, DOUG.Priestley, PRIEST, at Nortek, NORTEK.com. And if you have any other further questions, just shoot me an email and we'll get them answered for you. So with that, thank you for your time and look forward to the next Lunch and Learn. I believe the next technical Lunch and Learn that we're going to do in the springtime is going over the 14 SEER, some of the common questions that we get on the 14 SEER heat pump and some of the troubleshooting questions we get, and have Nathan do that for you all, and that'll be our next Lunch and Learn. So with that, thank you very much for your time. And again, you have my email address. If you have any questions, just shoot me an email and I'll get them answered for you. Thank you for your time again. Thanks.